Sandy. Okay, using 650 Fahrenheit degree clean to file ceramic greenware. After turn off her cleans, she must wait until the temper gauge reach 200 Fahrenheit degree before open the removing the ceramic piece. If the room temperature is 70 Fahrenheit degree, in that gauge read 600, and the room temperature is 70, and the gauge read 600 in 7 minutes. How long? Okay. Too many words. However, the idea is clear. It's typical cooling process, no? And this is the time. Okay, by the way, in our problem, it's expressed in minutes. And this is temperature in Fahrenheit degree. Okay, initial temperature is 650. Final temperature is always the environment temperature is 70. And this is the exponential decay. But the exponential decay is going down, but not to zero. You know, approach it to asymptotically to 70 degrees, que es the temperature of the room temperature. Entonces, they want to investigate. She wants to investigate important point case when you reach 200. Here, I suppose 200. Because this is important moment. Fahrenheit. This is Fahrenheit. Everything is Fahrenheit. Sorry. This is important moment for her because in this time is the time that she can open the clean and removing the ceramic piece. Okay. However, one condition is given, is the 600. Fahrenheit is reached at the 7 minutes. But for me, everything is clear. We have condition 0. Condition 0 is at t equals 0. 0 what? 0 minutes, no? Condition 1 is this. Is given because allow me to find the k value. K value, remember, is a parameter que give me how fast or how slow this temperature decreasing in that case because it's going down. No? And the condition 2 is the condition que something is missing. The temperature is given and you need to find the time. Do you understand very well the idea? I don't know why, but for me it's important to make this sketch. Give me one, physical idea. How it look like. So the formula is temperature to any time is equal final temperature plus initial minus final e to the kt. Yeah, I know very well the k is negative. Bueno, I want to find in your moment. Entonces, so far, I have the formula, specific formula for the hour problem is temperature final is 70 and temperature initial 650 minus 70 exponential kt. I'm subtracting 650 minus 7, 580. This is my specific equation applying in this problem. 580 equal to 8. And you apply that formula in the condition 0, in the condition 1, and the condition 2, depending the thing you know or you don't know, no? And the condition 0 is so big a work because look, 0 and 0. This is 70 plus 580 exponential k times 0. K times 0 is 1 because e to the 0 is 1. No, k times 0 es 0 and e to the 0 es 1. Entonces es obvio que this is invisible, no? And when you put together, the answer is 650. It's obvious, right? 650. This is expecting. This is stupid. However, I want to verification. Now, tempers to the specific time, que es 7 minutes, is the time in which you know the tempers, que es 600 Fahrenheit degree, is equal, you apply the same formula, no? 7 plus, 580, no parentheses. 580 e to the k multiplication by 7, que is the time and minute associated with this condition, no? Okay, now I'm moving 70, 600 minus 70 divided by 580 is equal e to the 7k. 600 minus 70 is 530. It's obvious. 530, 580, e to the 7k. Okay, you can cancel out if you want. 1 0 here. But actually, we have so far 53 divided by 58 is equal e to the 7k. Now, a crucial moment in which you apply natural logarithm. Always you apply natural logarithm because I know a natural logarithm together with the exponential give me undos each other and give me 7k. Now, logarithm of 53 over 58 divided by 7, this is k. Then you put in the calculator. However, I don't want to copy this result in the piece of paper because this is weird decimal, no? Let me see. Oh, I got it. You store in memory in your own calculator, no? Okay. Or leave it like that and you plug it in the condition too. It's a one possibility, no? I like storing memory. Storing memory. What kind of memory? In my calculator, I have a lot of memory. I select one memory que is associated with the same name, K memory. Boom. In my calculator now, K is this number. Okay, moving on now to condition 2. In the condition 2, you know temperature, but you don't know the time. So the temperature is 200. 200 is equal 70 plus 580 e to the kt. But k, I know. This is k. Okay. Now Tino is my goal. It's 270 minus 70. 270 no, 200. Sorry. 200 minus 70 divided by 580 equal e to the kt. Okay, 200 minus 70. Okay, it's obvious. 130. Now one more time. You delete 10, so say 13 or 58 is equal e to the kt. And one more time you apply natural logarithm of both sides. Natural logarithm of both sides. Entonces, natural logarithm of 13 over 58 is equal KT. What my goal is solve for K. Solve for T, sorry. For T, no, for K. Entonces, natural logarithm of 13 over 58 divided by K. But who is K? This is K. This is K is natural logarithm again. 53 over 58 divided by 7. This is T. Well. Just one possibility is this fraction. You flip it up, you put 7, natural logarithm of 53 over 58 divided by natural logarithm of 13 over 58. And that's it. It's basically divided by K. The student can memorize, so put in memory K. The thing you should do is logarithm of 13 over 58 divided by K. K I have in the memory, get that one. And you get the time, 8 minutes. Okay, let's do it. Clear. Natural logarithm of 13 divided by 58. And divided by K. I have in the memory, no? Memory K. K. Boom. Press enter. Okay, I got it. The answer is 116.12 something. And this is minutes. She need to wait. 116 minutes. Okay, 116 minutes is approximately 1 hour and almost 2 hours. Need to wait. Okay, 116. There you go. That's the answer. Look at that. Option C. Any question? Do you understand very well this problem or no? I know it's too long, sorry. But this is the level, no, of this subject. Any question? Clear?
Yes.
Okay, super. I have another similar. This is typical Newton calling. So we spent in the test 3 word problem. One problem is about growth, exponential growth, exponential decay, and Newton calling. Okay, thermometer reading 73. Again, Fahrenheit degree is placed a cold storage room. So I suppose que 73 is initial temperature. Now we are doing the problem 28 now, no? And the final temperature is always the temperature of the room, no? Cool storage with the constant temperature of 38. If the thermometer reads one temperature, arbitrary temperature, okay, by the way, it's 13 minutes. 13 minutes and 67. This is condition 1. Entonces, how long I need to find the time, temperature to the time I don't know, is equal 60. Okay. So this parameter, initial and final, give me the condition. Well, give me equation. The equation is temperature to any time is temperature final plus temperature initial minus temperature final. Remember, temperature initial always is bigger than final, no? Because it's cooling, E to the KT. The formula is 38 plus 73 minus 38. e to the kt. 73 minus 38 is 35. Yeah. The temperature to any time is 38 plus 35 e to the kt. To find the k value, I using the condition 1. The condition 1 is a condition that always we have whole information. We have the time and we have the temperature. Entonces es 67 is equal 38 plus 35 e to the kt. Okay, let's do it. Isolate k. No, sorry. At this moment, I replace the time for that condition. Okay, 13, no? Boom, 13. Let me show you here, over there. Okay, super. Now 67 minus 38 divided by 35 is equal e to the 13k. I prefer put the coefficients in the front. I don't know why. I like that. Minus 38. The answer is 29. Actually, we have 29 over 35. 29 over 35 equal e to the 13k. Apply logarithm on both sides. I know very well that this undoes each other at 13k. Therefore, k alone is logarithm of 29 over 25 divided by 13. This is my k value. Okay, apply the same formula. What formula? That formula. I just copy again. But in that case, I have k is this value. Okay, no problem. But the temperature is given 60. And the time I don't know. I need to compute that. This is my goal, T. 60 minus 38 divided by 35 is equal e to the kt. 60 minus 38 is 22 over 35. This is 35, sorry. 35. I make a mistake here. Is equal e to the kt. Apply natural logarithm again, both sides. Okay, we have kt, because I know very well that that parts does each other. Now, t, que my goal is natural logarithm of 22 over 35 divided by k. And who is k? K is natural logarithm of 29 over 35 again divided by 13. And if you want that 13, you put it here in the top, no? Equal t. Okay, so you compute. In the top, we have 13 times natural logarithm of natural logarithm of 22 divided by 35. Division by not necessarily parentheses, because it's only one monomial, one logarithm. Okay, logarithm of 29 divided by 35. Okay, press enter, and the answer is 32 point something. 32 point something. 32.097. Entonces es 32. 32. El problem talking about menos, ¿no? A ver, menos, ¿no? Es menos, yeah. Es menos, yeah. 32 menos. There you go. Boom. Any question? It's similar. And so we expect in the test, actually, when you have that, the test. one word problem of the exponential growth when the k is positive, one problem of the exponential decay when the k is negative, and one problem of the Newton Coulomb. And that's it, end the story. Okay, if you want, we can skip 29 no. Why not? Because it's another thing where I don't discussing in the lecture, no? That's a logistic. But it's easy. But okay. Skip it. Because in the test no. You don't see that. Any question before erase the board?
No.
No? Okay, super. This is a page number 9, no? It's a page number 10 now. Okay. 10. I suppose it's this. Okay? Yeah. That page. There you go. Okay, entonces, like similar idea we apply in number 30. No important for us. Let's focus now in the logarithmic equation. The first one, 31. Say logarithm of base 7 of t plus logarithm of base 7 of t plus 2 is equal to logarithm of base 7 of 35. I like so much put the parentheses, right? Because remember, this is a name of the function. log is the name. And it's a function notation, no? Some people omit the parentheses. Everyone understand very well. However, I like put the parentheses. When I see you condensing this logarithm in only one using the property number 5. And the condensing is clear. New multiplication is the logarithm of base 7 of t times t plus 2 equal logarithm of base 7 and 35. In that moment, if you have, similar to the thing that we are doing exponential, the logarithm is the same. So you have two logarithms and the base is the same because the argument is the same. And you put t plus 2 equal 35. And now you focus in the solution for this equation. It's a t squared plus 2t minus 35 equal to 0. I put it that way because I saw this quadratic equation. This quadratic equation is easy for solving because by factorization it's easy. It's 7 and 5 because 7 times 5 is 35 and 7 somehow minus 5 is 2. The sign is positive and negative. Therefore t plus 7 equals 0. T equals negative 7. Immediately I discard this answer because negative number inside the logarithm is completely undefined. No. And t equals 5. T minus 5 equals 0. T equals 5. Okay? As always happens in the logarithmic equation, you check it. You have to check it. But it's easy. It's easy because the substitution 5 in the original equation, logarithm base 7 of 5, plus logarithm of base 7 of 5 plus 2 gets 7 is equal to 35. Logarithm of base 7, sorry, of 35. One more time, you apply the property number 5, put together multiplication, and 5 times 7 is 35. Wow, it's true. Therefore, the solution 5 is okay. Any question? Solution is 5, no? F5. Only 5. Boom. Any question? Easy, eh? For you? Come on, guys, answer me. Say yes. Okay. Okay, let's move on to the next question. This question is another equation, logarithm of base 5 of y plus logarithm of base 5 of 13 minus y is equal to logarithm of base 5 of 30. Okay, exactly the same. Condensing in only one, logarithm of base 5 of y times 13 minus y is equal to logarithm of base 5 of 30. Therefore, y 13 minus y equals 30. I forgot to close the parenthesis here. So 13y minus y squared equals 30. Look like quadratic equation, no? But let me try to put in standard. In standard is, I propose you move everything to the right. So we have y squared minus 13y plus 30 equal to 0. You feel more comfortable, you interchange y squared minus 13 y plus 30 equals 30. This is easy also by factorization because the combination is obvious 10 and 3. 10 times 3 is 30, 10 plus 3 is 15. Negative off, negative. Y is 10 and y is 3. But I need to verification this solution because sometimes happen que work or no, or doesn't work. Checking for 10. Plugging in. Logarithm of base 5 of 10 plus logarithm of base 5 of 3 because of 13 minus 10 equal logarithm of base 5 of 30. It's obviously true because when you condense in this, apply the property number 5 one more time, it's 30. Wow, fantastic. True. 10 is good. And 3, I have no idea. Logarithm of base 5 of 3 plus logarithm of base 5 of 13 minus 3 is 10. Wow, it's symmetric. And when you condense it, you will get exactly the same. Both solutions are good. It's symmetric. So solution is 3 and 10. Boom. Any question? Come on, guys. Opinion. Everything is clear?
Clear.
Okay. Okay. Number 33 is logarithm of base A of the negative x. Don't worry for the negative. The only thing is change the sign. Plus logarithm of base 8 x minus 20 equal logarithm of base 8 of 96. One more time, we condense it. Remember, logarithm is not even, not odd, in which you can eliminate this sign. No. In this case, neither. Therefore, when you condense this and this together in one logarithm, well, of course, you have negative x times x minus 20 equal logarithm base A of 96. Again, same situation happen when you have two logarithms on the base is the same. It's because the argument is the same. So you copy minus x minus 20 equal 96. Well, distribute the property minus x squared plus 20x equal 96. I recommend you moving everything to the right. We have x squared minus 20x plus 96 equals 0. If you feel more comfortable, you put in that order. So you interchange, ¿no? And you get the same answer. Okay, entonces in this case, I can't do that. Maybe by factorization. Let me try. Oh no, so you don't see clear the combination, well, you apply the quadratic formula. Okay, you know very well. Again, the story. Let me see. Okay. No, it's easy. It's easy by factorization. The combination is 12 and 8. Let me check it. 12 times 8 and 16 carry the 196, yeah. And 12 plus 8 is 20. Good. But sign negative both. The solution is 12 and the solution is 8. I need to check it. The student that don't see the combination, you apply the quadratic formula. Do you want I apply the quadratic formula or no? Do you want? Or it's okay in that way? 12 and 8.
I think it's okay that way.
Okay. No, because sometimes you don't see the combination. So, well, so you don't see, don't be scared. You only apply the quadratic formula, and the quadratic formula mechanically give me the answer, right? Now check it. Wow. Okay, so now this is the weird part of this problem. In this case, the solution is given and the equation is positive. When you plug it in the original, like this, it's obvious que, for example, 12 here is negative 12, and logarithm of negative numbers is undefined, and logarithm of negative 8 and negative 12 is undefined. So therefore, what's the possibility to have solution? See, one solution is negative. When you plug in double negative becomes positive, this is defined, but in this case undefined both. Wow! So what is the answer of this stupid problem? It's no solution. Okay, the option C. Look at that. Do you see that?
Yes.
Okay. I suppose I don't put this kind of problem in the test. Because it's tricky, no? So in one moment you say, wow. I don't know if you are doing well or no. Okay, el logaritmo base 7. A ver, 35, yeah. Logaritmo base 7 of 3p plus 23 plus logaritmo base 7 of p equal logaritmo base 7 of 36. Again, condensing in only one. P times 3p plus 23 inside the argument of the logarithm function equal logarithm of base 7 36. Okay, one more time happen que 3p, p times 3p plus 23 is equal 36. 3p squared plus 23p minus 36 equal to 0. And this is a little bit more complicated doing by factorization. See, a little bit, no. Quadratic formula, A, B, C. A is 3, B is 23, and C is negative 36. Be careful with the sign, eh? So minus 23 plus or minus square root 23 squared minus 4 multiplication by 3 is A, multiplication by negative 36 is C, divided by 2 times 3. Okay. Of course, you're using the calculator, and be careful with the sign, guys. 23 squared is 529. Now the answer of the part is 529. And double negative becomes positive. Boom, be careful. And this is 12 times 36. is 432. And together is 961. And square root 961. And 31. Okay, good. Now we have so far 23 minus 23 plus and minus 31 divided by 6. No, this is 3. A is 3. I put the weird 3 here. You separate in two pieces, the piece positive and the piece negative. Negative 23 plus 31 divided by 6, and negative 23 minus 31 divided by 6. We have two solutions. 31 minus 23 is 8. 8 divided by 6, reduce and lowest term, 4/3. Okay, 4/3. 23 plus 31 is 54. 54 is negative 54. Negative 54 divided by 6 is negative 9. I suppose that this value is negative doesn't work in the logarithm equation. It's obvious, right? Well, no, it's not obvious. No, it's not obvious. Yeah, it's obvious. Yeah. It's obvious because here in P negative 9 is undefined. I said no. Delete. I need to prove somehow 4/3 to check it, double check it now. And the original, guys, you put logarithm of base 7 of 3 and with P is 4/3 times 4/3. It's obvious that this 3 is cancelled. It's just 4 plus 23 plus logarithm of base 7 of P, is 4/3, should be equal logarithm of base 7 of 36. Okay, this is 27, no? Okay, logarithm base 7 of, this is 4 plus 23 is 27. Plus logarithm base 7 of 4/3. One more time, we're condensing only one. Logarithm base 7 of multiplication is 27 times 4 divided by 3. Well, I do in that way, no? I divided by 3 is 1, divided by 2 is 9, and 9 times 4 is 36. Okay, matching perfectly. Now the answer 4/3 is correct. It's correct. Okay. Let me see. Yeah, that one. Any question? This was a little bit more complicated because the number is horrible, and definitely one of those good to illustrate when you don't see the combination of the factorization, you apply the quadratic formula. Okay.
Professor,
Go ahead.
how do we know when a negative value can actually work as like an answer?
Good question. You're plugging in the original. This is the original. Look at that. This is the original equation. This is the original equation. No, so no, it's no fact. The negative doesn't work always. No. You plug it in, okay? Logarithm base 7 of 3 times negative 9 plus 23 plus logarithm base 7 of negative 9 equal logarithm base 7 of 36. Wow! Automatically I see this guy is negative number inside the logarithm, totally undefined. And also here is exactly the same because it's negative 27 plus 23 is negative 4. A logarithm of negative 4 again is undefined. Okay, when you condensing together, negative times negative become positive. No, you need to plug it in the original equation. See, one logarithm contains inside the argument negative number, this is completely undefined. This is no solution. Got it? Miss?
Yes, thank you.
Okay. Wow. Let me see here. Boom. Okay. Boom. Okay. Now 35. 35 is logarithm, but no specification the base. So you need to suppose que when the no specification the base is because the base is 10. Right? It's a common logarithm. Okay. Again, we condensing this in only one. Okay. Now you know, same logarithm, same base is because the argument is the same. You apply distributive property, x squared minus ax is equal x minus 20. I'm putting a standard form because it looks like quadratic equation. So it's x squared minus ax minus x plus 20 equal to 0. X squared minus 9x plus 20 equal to 0. Oh, it's easy because the combination is 5 and 4. 5 times 4 is 20, 5 plus 4 is 9. And by factorization is easy. 5 and 4. And negative both. Negative, positive. Negative times negative is positive, no? And negative plus negative is negative. The solution is 5 and solution is 4. Okay. Maybe both solutions work or no. I don't know. And you go to the original and prove. See, work or doesn't work. Wow, what do you think? Well, when you plug it in here, no problema. But when you plug it in here, 5 minus 8 is negative 3. And 4 is negative 4. So no solution. Look at that. No solution. Do you understand much better now? Be careful. That I manipulate the original equation. I condensing, I remove the logarithmic, I get quadratic equation or another kind of equation. But this new equation is not equivalent 100% to the original. Therefore, you know, the logarithm is picky function because the logarithm is, the domain is not all real number. It's only valid for the positive number. Any solution when you plug it in the original to verify, so it's mandatory verify. The exponential, no. Exponential is nice. Exponential is the domain of the exponential function is all real numbers. So the exponential is super nice. But logarithm is super picky. And when you compute the solution, you plug it in, verify, double checking in the original equation. No transformation in the original. See, one argument is negative, doesn't work. Got it? Clear or confusing?
Got it.
Very well. Let's move on to the exponential. This is a classical exponential, but this exponential it's easy because you can manipulate both sides. Look, this is similar. 5 raised to x is equal to 25 raised to the x squared. Wow. Entonces now I know que 5 is 5, but 25 is 5 squared. So we can manipulate both sides in order to express it using the common base. So 5 raised to the 2x is equal 5 squared, replace 25 by 5 squared, raised to the x squared. So 5 raised to the 2x is equal 5, and you apply one more time the rule of the exponent. When you have different level of the exponent, is multiplication. Okay, in that moment, nice. To exponential, the same base, the argument of the exponent is the same. 2x is equal to x squared. Es obvio que tú descanses if you want. But suppose que you don't see that, no problema. You copy in standard form. Okay, to see more clear. You interchange, you put 2 x squared minus 2x equals 0, and the factorization, the great common factor is 2x, and we have x minus 1. And these two obviously do not participate in the game, because 2 is a factor that is not 0. If you, for example, you want to eliminate, you divide by 2 both sides. Entonces, 2 divided by 2 is 1, and 0 divided by 2 is 0. Entonces, I know I taken, using the zero factor property, the only factor que es potential 0, que es 0 and 1, x minus 1 equals 0, que es obvio. We have two potential solutions. I need to verification and the original equation. Oh, no, exponential is nice. Exponential never you need to verify, no? 0 and 1 in the story. Boom. No problema. Okay, do you understand every detail in this problem? Do you understand what is the reason que I mentally delete these two? The two que I highlight in gray color? Clear or no?
Yes.
Clear.
Okay. Okay. 37 is 32 raised to the x plus 4. Let me make it zoom to see if I saw clear or no. Okay, I suppose. And this is 2 to the 6x. Okay. Es obvio que the common base is 2, because 2 is 2. And 32 is 2 to the 5th power. You multiply 5 times 2, you get 32. And 2 to the 5th power raised to the x plus 4 is equal 2 to the 6x. Okay, this is not the only way to do that. However, it's a one possibility. No? Now multiplication, the exponent, this is 2 to the 5 multiplication x plus 4. I put a parenthesis because this is binomial, no? And this not necessary parenthesis because it's monomial. And now you have this exponential is the same base as because the argument is 5 parenthesis x plus 4 is equal to 6x. Boom. Distribute the property. 5x plus 20 equals 6x. 20 is equal to 6x minus 5x. 20 is equal to x. And this is 20. Just 20. Boom. Question. Are you boring to do this? Too much? Do you want to start a new chapter or not yet? We finished the review. What do you think?
We can finish the review.
Okay. Okay, don't worry. Okay, let's do it in 38. Okay, 38 is, wow, what the hell? It's 4 root 16 is equal 4 to the t. Well, there are many ways to do this, but if we can compute a 4 root 16. What is 4 root 16? What is the number that multiply by itself 4 times? Give me 16.
2.
2. If you put in the calculator, the answer is 2. Do you see that or no? Okay, entonces 2 es 2. And 4, no. 4 is 2 to the second power. Then you replace. This is 2 to the second power raised to the t power. Multiplication of the exponent. So the 2 is equal to 2t. And this exponent is 1. No? 1 is equal to t. Like the same reason that we discussed before. No? Same exponential, same base, t is 1/2. Boom. No bad. This chapter is no bad. This chapter is understandable. Well, no, not always. So I hear some students say, I never understand this stupid logarithmic. Okay? Logarithmic is useful, guys. You can see in another subject, physics. Well, you take calculus, of course, but in science, chemistry, physics. Okay, 39. 39 is 32. Wow, 32 raised to the x plus 3. I guess so. Let me make it soon to see more clear. Yeah, it's 3. Is equal 4. Is equal 4 raised to the 3x plus 1. I guess so. Let me make it soon again. I suppose it's 1. Yeah, 3x plus 1. Not clear, but I suppose. Okay. So you want to express and use a common base. 4 no. 2 yes. Because 4 is 2 to the second. And 32 is 2 to the 5th power. And 2 to the 5th power raised to the x plus 3 is equal to 2 to the second power raised to the 3x plus 1. One more time, you apply the rule of the exponent. When you have different level of the exponent, you multiply 5 times x plus 3 and 2 times 3x plus 1. Crucial moment. Same exponential, same base, therefore the argument is the same. The exponent, sorry. No argument, exponent. So automatically you convert this equation, the original was exponential equation to linear equation. No, the base is gone. The 2 is gone. So 5x plus 15 is equal to 6x plus 2. Okay, 6x stay minus 5x. I move to the right. 15 stay minus 2. 13 is equal to x. And you don't need to check in. No, exponential no. Exponential is nice. 13. Uy. What is the reason it doesn't work? I make a mistake or not? No. Do you see some mistake? Let me put in my calculator. My calculator solving everything. Let's see, 32. Power. Parenthesis. X plus 3 equal 4 power parenthesis 3x plus 1. Now I need to solve for x. 13, definitely. This is not this answer here, but it's 13. I solve by using my. No, the answer is 13. Good. Sometimes happen that this bank of information have mistake, no? Because it's human, no? The people who are doing that. Okay, number 11 question. Number 11 page. 11 page. PDF. Review test 3. Wow, too long. Let me see. We're doing this. Oh, now this. Okay. It's a continuation. Okay, 40. 40 is, well, is 3x equal 1 over 729. And 729 is 729. So your factorization, this number, is 3 to the 6th power. 729 is 3 to the 6th power. But in this case, reciprocal. Si es reciprocal, then is 3 to the minus 6, no? Remember, this negative indicate reciprocal. And now x is negative 6 in the story. Boom. 41. This was 40. 41. 7 raised to the parenthesis for x minus 4 is equal to 1 over 49 raised to the x minus 1. I guess so, no? I don't see very well. Yeah, es 1, I suppose. Bueno, it's easy because 49, I know very well, que es 7 squared. The problem is que es reciprocal, but it's okay. Si es reciprocal es negative, pone. Entonces 7 raised to the 4x minus 4 equal 7 to the minus 2 x minus 1. Okay, multiplication right now here. 7 minus 2 times x minus 1. Okay, I manipulate both sides. I'm using the same base, therefore the exponent is the same. Therefore, 4x minus 4 is equal minus 2x minus 1. You apply these three with the property here, and minus 2x plus 2. I try to solve for x. 4x stay here, plus 2x is equal to plus 4. This is 6. This is 6 also, x equal. Boom. Okay, let me check and see matching this solution or no. Oh no. No, something is wrong. Ah, yeah. Okay, where come from that for? Where come from? The problem is that I want to finish. I'm doing too fast. No. This is 2. And 2 plus 2 is 4. And this is 6. And this is 4 divided by 6 is 2/3. Let me see if 2/3 exists or not in the solution. No, I make a mistake. Wow. Okay. Let me check in at the beginning. Oh no, wait. Okay. This is 4x minus 4. And this is minus 2x plus 2. It's correct. This is 4x plus 2x equal 2 plus 4. I did well then. Okay, let me check in my calculator. So the answer is 6x equals 6, x equal 1. Maybe, I don't know, see if I write well or no. Okay, let me put in my calculator. I put in my calculator 7 exponential parentheses 4x minus 4 equal parentheses 1 over 49 plus the parentheses exponential and exponent parentheses again x minus 1. This is my equation. Okay, I solving this equation in my calculator. Solving this equation for my x. The answer is 1. Okay, again, another mistake here. The answer is 1. I verify my calculator. My calculator is fantastic. X equal 1. I did by hand. I check it, double check my calculator. And this answer doesn't match with the original. Okay, 42 now. Remember, our test is not multiple choice. You don't care for the choice. This is 3/5. 42. 3/5. Over what? 3y plus 9. 3y plus 9. Oish. 3y plus 9 is equal 27 over 125 4y. Okay. Okay, that's a fraction, but don't worry because I know the connection very well in between 3 and 27. So 27 is 3 to the third power. And 125 is 5 to the third power. You replace. This stays the same, but this no. This is 3 to the third power over 5 to the third power. Why not? Why not put together this like a 3 over 5 to the third power and multiply it 12y, right? So you know very well that 3 to the third power divided by 5 to the third power is equal 3 over 5 to the third power. Okay, this is the rule of the quotient when you have the exponent, no? The same exponent, right? Now finally, see you raised to the 4y, entonces now multiplication, and you get the sense. Okay, super. Now it's a crucial moment in which you have the same base, therefore the exponent is the same. 3y plus 9 is equal 12y. 9 is equal 12y minus 3y. 9 is equal 9y, y1. Let me see if it works or doesn't work. Yeah, work. Option C. Do you understand very well this manipulation? Was easy or was complicated? Was easy, eh? Because everyone knows very well that 27 is 3 to the third power and 125 5 to the third power. Likewise, 47 is similar. It's 10, no? No, yeah, 100 and 1000. Okay, it's 100 2x minus 1 is equal 1000 1 minus 6. Okay, solving this exponential equation. Well, I know that 100 is 10 squared and 1000 is 10 to the cubic power. Replace 10 to the 2 raised to the 2x minus 1 is equal 10 cubic raised to the 1 minus 6. And multiplication is 10 to the 4x minus 2 equal 10 to the 3 parentheses 1 minus 6. Well, in that case, no, I did multiplication, but no, more elegant, much better is you, for example, set out like that. 2x minus 1. Okay, ready. Two exponential the same base, entonces 2x minus 1 is equal to 3, 1 minus x. Is 4x minus 2 is equal to 3 minus 3x. Okay. So I try to grouping the turkey contain x to the one side. I recommend the left. And grouping, this is 3 plus 2, no? This is 7. This is 5. Divided by 7, the solution is 5 over 7. Let me check in. Yeah, option B. Good. Okay, almost we finish. You have no questions so far? How do you feel for this test? You feel good? You feel strong? I suppose here you are doing the homework. Any question you have about the homework? Remember, the tutoring is every Wednesday. Okay, I can clarify or by email. More or less. More or less. What part is confusing, Mariceli, no? Mariceli. Let me see in the chat. What part is confusing? I just need general practice. Okay, this is correct. But the practice, I suppose, okay, you take doing the homework, no? And the homework, when you are doing the homework, maybe you are stuck in one specific problem. So you send me email, I try to solve for you homework, no test. Yeah, I reply with the solution, or in the tutoring, I working only Wednesday from 11 a.m. to 4 p.m. Or if it's not good for you this schedule, you can use in the tutor assigning in this class, que Jose Alegre. Jose Alegre working every day, I suppose. Yeah, almost. Okay, let's move into the last page. Last page. Too long review. How many problems you need to get practice? The problem is, if you, wait. No, hello, this is too long. Okay, but this is easy, or relatively easy. Look, this is the identification. Actually, in the test, no identifications. You try to do the graph. And the most important thing is the graph of the logarithm have this format. Look, this is easy. Let's do it fast. Logarithmographic, we have two possibilities. Remember the famous universal point, 1,0, no? You have this graph like that. Or you have that graph like that. In both scenarios, we have here the vertical asymptote. And we have nothing in the negative part, because domain is only positive, not include 0. But how do you know get the blue or the red? Depending on the base. See, the base is a number fraction. So in between 0 and 1 is the blue, is decay. See, the base is greater than 1, is increasing function. The base in this case is 1/9. And 1/9, to say automatically you discard this possibility and this possibility. And we focus in B or A or D. Let me see the differences. The different. Sorry, I'm crazy. No. No, you discard increasing. No. Because the base is 1 over 9. No? Okay, but I suppose that the option C is correct. Because passing through the famous point 1,0. This no. Because we have no transformation. So it's the basic. The only is the base case. Okay. Do you understand the idea or no? I can explain in different way. So but suppose que in the test I need to do the graph. No, it's multiple choice. Okay, it's super easy because, well, because you open Desmos, no? And you see. However, suppose by hand. You plot the famous point, this case 1,0. And you know in 1 over 9, see es logaritmo 1 over 9 of x function. In 1 over 9, because logarithm of, when there are perfect coincidence between the number and the argument and the base, the answer is 1. 1 over 9, you know, you divide this 7 and 9 portion using my imagination, you see. And this point is 1. This point is the point 1 over 9, comma 1. And another point would be logarithm 1 over 9 of 9, que es el recíproco. El recíproco dice, el recíproco es negative 1. Entonces 9, I suppose que 9 is here. This is not a perfect scale. It's negative 1. Okay, this point is the point 9, comma negative 1. And the curve look like that. Important that you have asymptotically vertical asymptote here at x equals 0. Do you understand very well? This is the most important.
Yes.
Recognize the base is a fraction or less than 1 or greater than 1. Si es less than 1, it's the curve like a blue. Si es greater than 1, it's a curve like a red. That's it, super easy. Okay, next page. I did that. Wow. This one. Well, this is a little bit. Oh, let me see. This is weird. Logarithm base 3 of y equal x minus 4. Using transformation to graph the function. Write the domain and range in the interval notation. Determine the vertical asymptote. And actually, it's weird here because no. Okay, this is not good. This is actually logarithm base 3 of x is equal y minus 4. Okay, because if you have y inside, the logarithm is exponential. And this graph do not correspond with the exponential. Something is wrong. Okay, so now you fix it up, and you copy that. This actually is logarithm base 3 of x plus 4 equal y. Well, I know that the base is greater than 1. Entonces, this is logarithm like that, not like that, because the base is 3. And plus 4 is, this is weird. All right, let me see. No. No, something. Ah, okay, okay. Yeah, 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 okay. No, no, no. No, it's weird. Now, let me see again. I don't understand very well this problem. Using transformation to graph the function. Forget about this. This is weird. I don't know. I suppose I don't do that never, right? You see, yes, logarithmic.
I think number 24 on the test is similar to.
It's similar.
Yeah.
Oh, let me see. Because actually, okay. See, I realize, okay, this is well. The equation is correct. You transform this to exponential. And when you transform it, the base is 3, the exponent is x minus 4, and the answer is y. So this is exponential, and exponential look like that. Okay, this is 3, this is the famous point 0.1, and this is, but no vertical, no vertical. Something is weird. No. Let me see the next question. Maybe this question is horrible. Horrible, no, it's wrong. Let me see the next. So next is similar to say I am very, very concerned. Okay. Let me see. Okay, let me see. That one. This is much better. Okay, look, this is the 45 is crazy. Forget about 45. This is clear. This is clear. Look. I suppose que the question you say 27 in the test is similar to this. This is y equal minus 2 plus logarithm base 4 of x. Okay, it's doing. So you can put in decimal. However, let's do it in my hand. Look. Okay. Logarithm base 4. You have the famous point here. Que es the point. Que es the point 1,0, no? 1,0. And you have, okay, because logarithm of 1 base 4 of 1 is 0. Well, actually, it's 0 minus 2. Okay, however, let's do it. This is easy. Look. Plug it in. Suppose add x equal 1. Y is equal minus 2 plus logaritmo base 4 of 1. Y I know very well que logaritmo base 1 es 0, entonces the answer is negative 2. At that point is no 1, 0, es 1, negative 2. Why 1, negative 2? Because we have one vertical shift 2 unit down. Entonces this is 1. This is 1. But this is negative 2, negative 1, negative 2. This point. Okay, this point is 1, negative 2. Good. Suppose now at x equal 4. How do you know what value you select? Because you select the same number of the base or power of this. Es negative 2 plus logaritmo base 4 of 4, que es 1. Entonces minus 2 plus 1, que es negative 1. Then 4, 2, 3, and 4, the answer is negative 1. That point is the point 4, negative 1. And another interesting is 1/4. Okay, y is equal minus 2 plus logaritmo base 4 of 1 over 4, que es negative 1. This is negative 2 minus 1, que es negative 3. So 1/4 approximately is here, is negative 3. Okay. Okay. Our graph, this is 1/4, negative 3. Our graph look like that. Discontinuous. And this we have again the vertical asymptote. The vertical asymptote doesn't affect by the vertical shift because the original logarithmic function has, you know very well, vertical asymptote at x equals 0. But the only thing that we are doing is translation move down the entire curve. However, the asymptote stays the same because the asymptote change if you are doing the horizontal shift, but in this case no, we are doing vertical shift. Entonces, en my opinion, es obvio que corresponde with the option D. Look. Yes or no? Yes or no?
Yes.
Do you understand? 45 is crazy. 45 is crazy because contain the y inside the logarithm. Entonces this is completely exponential and the graphic is given and the problem never corresponded with the solution. This exponential is another curve, no logarithmic, and exponential have no vertical asymptote, have horizontal asymptote. Do you understand that the equation 45 is crazy? I need to remember next time. I teach him one time this. I use the same package. I suppose I give the same solution. Entonces, everything okay? Do you understand? Do you follow me?
Yes.
Okay. Let's move on to 47.
Do we still see 24 on the test since it's similar to the 25?
45?
Yeah.
Wow. Let me see. Okay. No, 25 is easy, it's understandable. This, do you see? This is this, look. Do you see this?
Oh, I meant 24.
Yes. Determine the vertical. Okay, this is for me have no sense this because this is logarithmic. Okay, logarithm base 3 of y is equal to x plus 1. But this is not explicit. So you transform it to exponential. The base is 3. The exponent is x plus 1 is equal y. And this graph, let me see. See, no, it's okay. I got it now. Okay, the problem is that this ABC corresponded with the graph of the 23. Yes or no? And 24 and 24 have no question. Let me see. What is the question in 24? Determine the vertical. No. Forget about 24. This is crazy. How do you see that? Forget about 24, guy. 20, 25. Skip 24. No. Okay, no 24. Okay? Because what is the question? Graph the function. For me, it's clear 23. Yeah, I suppose. I don't know. What is the question in the 24? What do you want to find? The same? No. Okay? This is exponential, and this exponential have no vertical asymptote. Do you understand the idea?
So on the test, nothing. We don't do 24 at all.
Oh, well, all right. Let me know what is the question.
On the test, 24 we don't do at all, right?
No, don't do that.
Okay.
Don't do that. Because suppose you try to do this. What is the question? Because ABC is referred to the 23. Maybe repeat again ABC and 24. But no sense, because talking about vertical asymptote, and actually it's no vertical, it's no logarithmic function, it's exponential function. An exponential function have no vertical. Okay? So 24, no. I need to remove this in next semester. Okay. All right, 20, review. Review. I suppose it is. Is it clear? Okay. 47. Y equal logarithm by 3 of x minus 4 minus 3. So we have here, you know that the base is greater than 1. It's obvious that our exponential is in that direction, right? No, in this direction. You discard this solution and this solution. No, it's increasing. Now we have it's easy. We have that transformation, que es horizontal shift 4 units to the right. Okay, that is the reason that our asymptote, vertical asymptote, is moving 4 units. So here, this is x equal 4. In both cases, but you have minus 3, que es a vertical shift. 3 units down is obvious with this, right? Makes sense?
Yes.
Okay. Let's do in the last 48, 49, and 50. This is easy. Look, 48. Compute or simplify this expression. Natural logarithm of 1 over e to the 6th power. Well, this is natural logarithm of e to the minus 6. Reciprocal, right? Negative exponent. And you know very well que logarithm and exponential undo each other when there's the same base. The answer is negative 6. Boom. Super easy. Now logarithm base half of 32. And remember, when the base is fraction and the number inside the argument is no fraction, you expect, this is a contradiction, no? And you expect negative, because somehow the exponent negative indicate always reciprocal. Flip it. But suppose I don't know. You put x, you convert to exponential, the base is 1/2, the exponent is the thing I try to find, equal 32. Okay, now in that moment I switching my logarithmic problem to exponential problem, and this is relatively easy to find. How you find? Well, I know that 1/2 is 2 to the negative 1, and 32 is 2 to the 5th power. Entonces 2 to the negative 1 raised to the x equal 2 to the 5th power. Multiplication, 2 to the negative x equal 2 to the 5th power. And you have x is negative 5. Well, no, actually, negative x is equal to positive 5, but I multiply or divide by negative 1 both sides is negative 5. This is one possibility. Another possibility is using the famous chain of base formula. You compute the logarithm of base 32. Of course, that logarithm is in the calculator. And logarithm of 1/2. And you get actually directly negative 5. Clear or confused? Negative 5. Clear or confused?
Clear.
Okay. Now, that's page. Wow, I suppose que it's not too long. Okay. Okay, last question. Hopefully easy. What do you think about this? It's a common logarithm of 0.000. How many 0? 1, 2, 3, 0, no? 1. Oh, let me see, yeah. You put it directly in the calculator, no? You can or no? Let me see. Log of 0.1231. Negative 4. Yeah, the answer. However, if you want to apply by hand, it's x. And the base is 10. And this is 1/10 to the 4th power. So it's 10,000. Reciprocal 10,000. Que es 10 to the negative 4. Therefore, same base, same exponent. Got it? Yeah, I remember something. The last time I teach in this class, some students say, Professor, I don't understand the question 24. Don't, forget about question 24 in the test. No question 24. Okay. This is good or not good? I don't know. If you want, I create another, I send to you or no. It's okay?
Yeah, it's okay.
It's okay. Okay, entonces we have time to start new chapter, no? No, no, definitely not. Okay, too much for one day. Well, to say next time, remember, guys, March 24, due date for the written test plus online test. You submit the online, and you have to the entire 24 at midnight. I will grade both tests this Friday. Okay, and that's it. Okay, everything's clear?
Thank you, Professor.
No, pleasure, anytime. Okay, bye-bye, guys. See you.